Section 9.3, Request Rate Limiting with Spring Cloud Gateway and Redis. Rate limiting is a pattern used to control the rate of traffic sent to or received from an application, helping to make your system more resilient and robust. In the context of HTTP interactions, you can apply this pattern to control outgoing or incoming network traffic using client-side and server-side rate limiters, respectively. Client-side rate limiters are for constraining the number of requests sent to a downstream service in a given period. It's a useful pattern to adopt when third-party organizations like cloud providers manage and offer the downstream service. You'll want to avoid incurring extra costs for having sent more requests than are allowed by your subscription. In the case of pay-per-use services, this helps prevent unexpected expenses. If the downstream service belongs to your system, you might use a rate limiter to avoid causing DOS problems for yourself. In this case, though, a bulkhead pattern, or concurrent request limiter, would be a better fit, setting constraints on how many concurrent requests are allowed and queuing up the blocked ones. Even better is an adaptive bulkhead, for which the concurrency limits are dynamically updated by an algorithm to better adapt to the elasticity of cloud infrastructure. Server-side rate limiters are for constraining the number of requests received by an upstream service, or client, in a given period. This pattern is handy when implemented in an API gateway to protect the whole system from overloading or from DOS attacks. When the number of users increases, the system should scale in a resilient way, ensuring an acceptable quality of service for all users. Sudden increases in user traffic are expected, and they are usually initially addressed by adding more resources to the infrastructure or more application instances. Over time, though, they can become a problem and even lead to service outages. Server-side rate limiters help with that. When a user has exceeded the number of allowed requests in a specific time window, all the extra requests are rejected with an HTTP 429, too many requests status. The limit is applied according to a given strategy. For example, you can limit requests per session, per IP address, per user, or per tenant. The overall goal is to keep the system available for all users in case of adversity. That is the definition of resilience. This pattern is also handy for offering services to users depending on their subscription tiers. For example, you might define different rate limits for basic, premium, and enterprise users. Resilience 4J supports the client-side rate limiter and bulkhead patterns for both reactive and non-reactive applications. Spring Cloud Gateway supports the server-side rate limiter pattern, and this section will show you how to use it for edge service by using Spring Cloud Gateway and Spring Data Redis Reactive. Let's start with setting up a Redis container. Section 9.3.1, Running Redis as a Container. Imagine you want to limit access to your API so that each user can only perform 10 requests per second. Implementing such a requirement would require a storage mechanism to track the number of requests each user performs every second. When the limit is reached, the following requests should be rejected. When the second is over, each user can perform 10 more requests within the next second. The data used by the rate limiting algorithm is small and temporary, so you might think of saving it in memory inside the application itself. However, that would make the application stateful and lead to errors, since each application instance would limit requests based on a partial data set. It would mean letting users perform 10 requests per second per instance rather than overall, because each instance would only keep track of its own incoming requests. The solution is to use a dedicated data service to store the rate-limiting state and make it available to all the application replicas. Enter Redis. Redis, redis.com, is an in-memory store that is commonly used as a cache, message broker, or database. In Edge Service, we'll use it as the data service backing the request rate limiter implementation provided by Spring Cloud Gateway. The Spring Data Redis Reactive project provides the integration between a Spring Boot application and Redis. Let's first define a Redis container. Open the dockercompose.yml file you created in your Polar deployment repository. If you haven't followed along with the examples, you can use chapter 09/09 begin/polar deployment/docker/dockercompose.yml from the source code accompanying the book as a starting point. Then add a new service definition using the Redis official image and expose it through port 6379.
Listing 9.11, Defining a Redis Container.
Next, open a terminal window, navigate to the folder where your Docker compose.yml file is located, and run the following command to start a Redis container.
See this code?
In the following section, you'll configure the Redis integration with Edge service. Section 9.3.2, Integrating Spring with Redis. The Spring Data project has modules supporting several database options. In the previous chapters, we worked with Spring Data JDBC and Spring Data R2DBC to use relational databases. Now we'll use Spring Data Redis, which provides support for this in-memory, non-relational data store. Both imperative and reactive applications are supported. First, we need to add a new dependency on Spring Data Redis Reactive in the build.gradle file of the Edge service project, Edge service. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 9.12, Adding Dependency for Spring Data, Redis Reactive.
Then, in the application.yml file, configure the Redis integration through the properties provided by Spring Boot. Besides spring.redis.host and spring.redis.port for defining where to reach Redis, you can also specify connection and read timeouts using spring.redis.connectTimeout and spring.redis.timeout respectively.
Listing 9.13, Configuring the Redis integration.
In the next section, you'll see how to use Redis to back the request rate limiter gateway filter that provides server-side rate limiting support. Section 9.3.3, Configuring a request rate limiter. Depending on the requirements, you can configure the request rate limiter filter for specific routes or as a default filter. In this case, we'll configure it as a default filter so that it's applied to all routes, current and future. The implementation of request rate limiter on Redis is based on the token bucket algorithm. Each user is assigned a bucket inside which tokens are dripped over time at a specific rate, the replenish rate. Each bucket has a maximum capacity, the burst capacity. When a user makes a request, a token is removed from its bucket. When there are no more tokens left, the request is not permitted, and the user will have to wait until more tokens are dripped into its bucket. Note: if you want to know more about the token bucket algorithm, I recommend reading Paul Tarjan's Scaling Your API with Rate Limiters article about how they use it to implement rate limiters at Stripe. See this link. For this example, let's configure the algorithm so that each request costs one token, Redis rate limiter requested tokens. Tokens are dripped in the bucket following the configured replenish rate, Redis rate limiter replenish rate, which we'll set as 10 tokens per second. Sometimes there might be spikes, resulting in a larger number of requests than usual. You can allow temporary bursts by defining a larger capacity for the bucket, Redis rate limiter burst capacity, such as 20. This means that when a spike occurs, up to 20 requests are allowed per second. Since the replenish rate is lower than the burst capacity, subsequent bursts are not allowed. If two spikes happen sequentially, only the first one will succeed, while the second will result in some requests being dropped with an HTTP 429 too many requests response. The resulting configuration in the application.yml file is shown in the following listing.
Listing 9.14, Configuring a request rate limiter as a gateway filter.
There's no general rule to follow in coming up with good numbers for the request rate limiter. You should start with your application requirements and go with a trial and error approach. Analyze your production traffic, tune the configuration, and do this all over again until you achieve a setup that keeps your system available while not affecting the user experience badly. Even after that, you should keep monitoring the status of your rate limiters since things can change in the future. Spring Cloud Gateway relies on Redis to keep track of the number of requests happening each second. By default, each user is assigned a bucket. However, we haven't introduced an authentication mechanism yet, so we'll use a single bucket for all requests until we address the security concerns in chapters 11 and 12. Note: what happens if Redis becomes unavailable? Spring Cloud Gateway has been built with resilience in mind, so it will keep its service level, but the rate limiters would be disabled until Redis is up and running again. The request rate limiter filter relies on a key resolver bean to determine which bucket to use for each request. By default, it uses the currently authenticated user in Spring Security. Until we add security to Edge service, we'll define a custom key resolver bean and make it return a constant value, for example, anonymous, so that all requests will be mapped to the same bucket. In your Edge service project, create a rate limiter config class in a new com.polarbookshop.edgeservice.config package and declare a key resolver bean, implementing a strategy to return a constant key.
Listing 9.15. Defining a strategy to resolve the bucket to use per request.
Spring Cloud Gateway is configured to append headers with details about rate limiting to each HTTP response, which we can use to verify its behavior. Rebuild and run Edge service, /gradlew boot run, and then try calling one of the endpoints.
See this code.
The response body depends on whether catalog service is running or not, but that doesn't matter in this example. The interesting aspect to notice is the HTTP headers of the response. They show the rate limiter's configuration and the number of remaining requests allowed within the time window, 1 second.
See this code.
You might not want to expose this information to clients in cases where the information could help bad actors craft attacks against your system. Or you might need different header names. Either way, you can use the spring.cloud.gateway.redis rate limiter property group to configure that behavior. When you're done testing the application, stop it with Ctrl+C. Note: when the rate limiter pattern is combined with other patterns like time limiters, circuit breakers, and retries, the rate limiter is applied first. If a user's request exceeds the rate limit, it is rejected right away. Redis is an efficient data store ensuring fast data access, high availability, and resilience. In this section, we used it to provide storage for the rate limiters, and the next section will show you how to use it in another common scenario: session management.